Once you've understood that the car is an overconstrained system, then why, when you change the spring rate on the front, does the car more understeer? If you have that question, and if you know that the tire is black, round, and highly nonlinear, you have got 95% of the vehicle dynamics covered.
Welcome to the Your Data Driven podcast. If you like this podcast, be sure to visit our website at yourdatadriven.com for more useful help and advice on setting up your race car, mastering data analysis, and driving faster. Welcome to episode 41. Today I'm joined by ex-Formula One suspension guru Paul Fickers. Paul has been working to develop suspension systems on road and racing cars for nearly 30 years. He has also developed quite an astounding suspension development tool within Excel. In his own words, it's got completely out of hand. In this show, we discuss all things suspension, how you can do the basics right, and what the basics even are. We do get a little bit nerdy at times, but go with it, because it's an absolutely great conversation. And if you've ever had questions about how your car suspension works, then this is the perfect show for you. So, without further ado, grab your notepad, grab a coffee, sit back, and let's hear what Paul has to say. You may know that at the end of season 1, I wrote the Motorsports Playbook, a summary distilling the first 20 shows into nuggets of wisdom. I made the notes so that you don't have to. If you've not got it yet, go and grab yourself a copy from the website. So, welcome, Paul.
Thank you.
It's a real pleasure to have you on the show today. We started off doing a bit of an intro, and between each other, I thought, you know what, let's just get the show going, and we can do that so that everyone can hear too. You have put together this amazing bit of software, and I want to talk about it and tell everyone about it today because I had the pleasure of using it not so long ago, and it's brilliant, to be honest. And what you've been able to do in the world of Excel is quite staggering, if I'm honest with you. I'm really good at Excel, and I see what you've done, and I'm just like, wow, okay, I wasn't that good after all. So, but before we get too ahead of ourselves, it would be lovely to have a bit of a background about you and how you got into this world, how you created a sort of suspension and software tool, what you kind of get up to as a day job, and maybe work towards one or two takeaways that people listening, so more of the amateur club level motorsport participant, can kind of get from this engineering, this professional engineering approach to particularly suspension and setup, because there's a lot of kind of folklore and paddock kind of wisdom. Suspension and setup is complicated, and there's lots of interrelated stuff that's going on. And I totally understand why people kind of go, well, I don't really know, so I'll just experiment and do the best I can. But when a tool like yours pops up and people can see, actually, yeah, I can ask some of these questions that I'm asking in a practical sense, and I can do them on the computer much, much more quickly and maybe more rigorously, I can then work towards a much better understanding of what's really going on in my car. So, but if we can sort of just work towards it, maybe one or two things that you think, people might be able to solve themselves, as well as, obviously using your software, but, outside of that too. So how does that sound? Should we set that up for a challenge?
Yeah, absolutely. First of all, let me thank you for being in the show, because I'm very honored, and I started these tools, just for fun, actually, just about 30 years ago when Axel wasn't really around. It was Lotus 123. I always wanted to be a suspension chassis engineer, and tools like Adams were out of my reach. So, and in my days, it was 1989 when I had to do my thesis, and I studied in Germany, in Aachen University. And, in 89, well, the world changed quite a bit, just nowadays again, when the wolf came down and all the money in the universities went to East Germany. So and I wanted to do a nice study on a sports car. So I had to get myself a sports car, and then I got the Donkervoort, which is the Dutch Lotus Super 7 derivative and the equivalent of Ferrari in the Netherlands. And I got Mr. Donkervoort convinced that he should give me a car to optimize his suspensions. So that was when it all started. But unfortunately, I didn't have any software. So I started out writing it in Fortran 77.
Well, hang on a second. Why did you decide that you needed software? Okay, so this is quite an important point for people listening. You know, what is it that it's going to do for you? Why did you think, oh, this is going to help?
The key was that I wanted to show Mr. Donkervoort that you could go to a multi-link suspension. That was the key point. You know, the double wishbone suspension, that was, you know, state of the art in those days, and everybody could work around this. But I wanted to go beyond that. You know, it was in those days, everybody was talking about multi-links. And unfortunately, for a proper multi-link suspension, you do need a computer.
I totally agree. I've done a few of them myself. It's just, that messes with your mind.
Exactly. They tend to be very particularly complex, and it becomes very difficult to visualize what's going on in your mind. So that was the key reason why I said, well, I need a software. And unfortunately, we didn't have Adams at the university yet. We had a software which was Abacus, which was finite element, nonlinear finite element, but that was a bit complex. So and then I read a book which I always refer to, which is from Wolfgang Maczynski, so the Pope of suspension design. And it took me about 10 years to understand the man, so it's very complex.
Well, I think this is a good point, though. We talk about this, right? But there's a lot of books. Like, so there's I've got them all here on my shelf. There's like race car vehicle dynamics, Millikan. There's chassis dynamics. There's the multi-body systems approach, the Damien Harty. But these books are quite dense. You know, they're quite advanced level maths, and I think maybe that's a reason why books. I don't know if you're familiar with a book like the Alan Staniforth type book, which was very much an empirical approach, where he created the string computer and things like this, which was much more practical for people who aren't necessarily comfortable with maths. But I think to hear that you even struggled with this kind of book is comforting, I think, for people.
I actually struggled quite a lot with it, because I do consider myself to be a mediocre mathematician. Probably I consider myself to be a good mechanical engineer, but the mathematics and vector algebra are things that people don't really like. And you don't do that stuff for fun, and that's also one of the reasons why I wrote my little memoirs. The 5 easy steps, or the 5 fundamentals of the 10 easy steps, because those are the ones that help me going, and that's what I try to get to the students that I sometimes have the honor to teach to, that there is something important, but unfortunately you need a computer for multi-link suspensions, and that's why I decided to write it myself. It was in Fortran, and then at a certain point in time, Excel came around, and you start using that tool at school, at university, and said, hey, this is really quite a nice tool. It does everything you want, and that's why I kept progressing with the tools. It wasn't like the vision, you need to do everything in Excel. But those were the tools I have at my disposal, and I kept just continuously working on it. So what you see is actually 30 years of Excel. And luckily, or you could also say sadly, I spent about 15 years of my life in hotel rooms. And in the evening, you can go to work out, or you can do something else. And I decided to use that time to work on my tools to make it something better. And one thing led to the other. You got engineers asking me, well, could you do this? And could you do that? I said, well, hang on there. Yeah, we can have a look at it. And it just got out of hand, horribly out of hand.
It's completely out of hand. It is honestly, when I first started using it, I was just like, you've done this in Excel? I'm about to say, I'm comfortable with Excel. I have a course on VBA for motorsports. People can go and grab it on the website. And, you can tell that, that's the basics of how to get going. But then you just think, were you mad to try some of this stuff? You've got the 7-post rig, you've got multiple frequency stuff, which Excel doesn't really handle very well. I mean, it's just fascinating. So
the basics work always pretty quickly, but then you got obviously the user interface and to you get the pride to do it properly and make it understandable. So I think if you take 80% of the interface out, you could still work with it as an engineer, but it would probably be most of the people that actually use it would be would be having some troubles in understanding it. And it's also quite funny because I started with some very light versions, but all my clients, they always want the super duper expert pro version. And then they say, well, this is complex, that nobody wants to start at the beginner's level. They always want to have the full singing, all dancing. I think that's the key thing, and it's unfortunately on suspension design, you need to do a few steps in between before understanding everything.
Yeah. So what do you do like now for work? So that was when you were at university. So tell us a bit more about your journey through life, because you're very much involved in this still today, aren't you?
Yeah, from university, the Aachen University was very close to Cologne. So I got the offer to come to work as a CAE engineer in Ford, Advanced Control, where I started working with Adams. And quite luckily, there was one of my bosses was an ex-motorsports engineer, director, who had excellent ties to Sauber. And Sauber had some problems with their car in those days. We're talking about 1994, 1995. They got the motor from Michael Schumacher's car from Benetton, so they got the works deal. And they had some problems with suspension. And then they said, well, maybe, Paul, you should have a look at it. And I was all ready for it. That was my dream. And the actual quite interesting thing is I was working in Ford on the Ford Transit, which is it's not really a race car. And then I could work on Formula One cars. And I got an assignment to build up the simulation department at Stewart Grand Prix from 1997 until 2000. So I got into Formula One and all the thing that is going on now, bounce and pitching modes and everything, four-poster test procedures. We put that all in place. And actually that work is the baseline for my suspension tuning module. So it's everything in there. And coming from in 2000, Ford said, you've been playing around enough in racing. Well, we want you back. So I came back to into the mainstream engineering, and I got the Focus RS to be done, which was quite a challenging project because it had to be as indulging as a Subaru STI or a Mitsubishi Evo, which was for a front-wheel driven car. Pretty difficult to get to it, but we got it to a level where everybody says, well, that's great.
I've got something for you on the Focus. So I worked as a placement student in Cologne on the production line design for the Focus, and that Focus RS was everyone was super excited about that car when it first came out. You must have been over the moon about it, really. Although people wanted it to be four-wheel drive, didn't they? And then it was a bit disappointing.
Yeah, everybody wanted it to be four-wheel drive, but we only could do front-wheel drive. And then based on the work that we did there, we developed as a team also the famous Rayvon knuckle front suspension, for reducing torque steer.
I do remember that one, yeah.
Yeah. And I'm a holder of the patent. So
no, really?
Yeah. I'm one of the 5 people that own the patent within Ford. So that was the Mark II Focus RS. We had that, so that was quite nice to be involved in all of that.
Because you talk about multi-link as well. And sorry for people listening if this is all a bit dull. But we've gone off straight to quite technical stuff. But the lovely thing about that Focus was the multi-link rear suspension.
It was great, and we tuned it. The multi-link rear suspension was a specific one, so with the blade control arm. So it was a very nice application of a multi-link. And to be fair, for the Focus itself did set a new standard in that area, and the group of people that were involved with it, we were very, very proud, and we knew exactly what we were doing. So we when we were developing the car, it was. Ford in those days with the Focus, before the Focus wasn't really a vehicle dynamics car or a handling car brand. But we had a group of people, and many people came from Aachen University who were eager and keen to show the world what we could do. And we did it. And when it came out, it was a game changer, the car,
It was really efficiently designed as well. So again, I as a suspension designer, I was working in that world, and it was literally, you look at it and you just think, that's a multi-link rear suspension, but it was cost, because the problem with the multi-link at the time was, it's too expensive, we can't do all this thing. And the way in which that you guys basically got around that and made it affordable for Ford to, at some point, it's had to sign that off.
The press knuckle made it happen. So because the Mondeo had a forged knuckle and the Focus had a press knuckle, and that was the one that could make it work. we spend hours and hours with chassis engineering on how to make it work, and they get all the kinematics and most of all the elastic-kinematics to work. Because the one thing I always say is, like, it's not really the kinematics that make a good car. It's the elastic-kinematic, the compliant behavior. And that's where with the multi-link, where you can go so much more beyond than a simple McPherson suspension. You can tune the system a lot more, but you do need to understand what it's doing, and you need some tools for that.
So one of the things I was just having a conversation just the other day about this. In motorsport, even at quite a high level, the compliance, in my experience anyway, I might just have not seen it, but in my experience, people don't really consider the compliance, or they don't really consider the bump characteristics too much of the car, of the suspension. And having developed suspension myself with K&C rigs and Adams models, and with all the compliance that we're trying to build in for the comfort, but you're also really focusing on the tune as well, and the tuning of it with the rubber. And it's amazing how much difference it makes.
Even for racing, if you look at the chain of stiffnesses, you have a rolls joint, you have a bushing or another rolls joint, you have a bracket, you have a link. So if you add them all up, it quickly becomes compliant. And especially, I would dare to say that the last 10, 15 years in Formula One suspension development have been around optimizing compliances, because at the end of the day, every material is flexible. It's only a little bit, but at the end of the day, it's flexible. And the trick is to work the compliances into your advantage, not into your disadvantage. That is the key thing you should do.
Exactly. It's like, well, you need to, it's almost like you have this saying in sport, you've got to work with your situation, not against it. And it's just accept the fact that, this thing's going to move. So if you have a lateral load coming in on the tyre, do you want it to toe in or out? Because it's going to go one way or the other. So, just choose.
Exactly. And if you have a braking load on the rear tyre, do you want it to go to toe in or to toe out? Those are the key things to do. And that is where in my work, I spend a lot of time in optimizing that thing. You can design kinematic identical suspensions, which elastic-kinematic have complete opposite directions. So that's why I keep telling people, do not focus on kinematics only. Certainly do not optimize kinematics only, but do look at the compliant thing. If you can have a perfect kinematic system, which is horrible in the elastic kinematics. If you put your steering rack on the wrong position, you'll be having problems for the rest of your life on that vehicle. So you have to start with the proper design. How do I want my elastic-kinematics? And then you work your kinematics out. So the opposite way around.
I'm completely in agreement with you. And it's funny, sometimes when I have that conversation in a paddock environment where it's like, well, no, it's stiff. And it's like, it's not stiff. It's just you can't see it moving. We actually had, a little while ago, I used to work at a place called Myra, which is a...
Yeah, I know Myra for sure.
Mm-hmm. So I ran the vehicle dynamics team there for a couple of years, and they have a K&C rig there.
They have 2 K&C rigs now.
Ah, okay. Well, I haven't been there for a while. So, they were on about getting a new one with an inertia sensor. So hopefully they have done that. Every year, we used to have pretty much all of the UK-based Formula One teams come up and spend a couple of days with us doing K&C rig testing. And it was both to look at the compliance of the stiffness distribution of their chassis that they put up together. But also, I think, some of them have got their own rigs, to try and validate their own rigs and just make sure that, what they had in their models was accurate. And it was funny because we used to have the conversation about the non-believers in things like the mounting of the rocker arm, for example. The stiffness of that was something that people hadn't really considered. And then it was like, okay, we really need to make this stiff. Otherwise we're not really using the spring properly, sort of thing. So
yeah, I've been lucky enough, or been suffering enough to go through all of that. In the days when I was working with Stuart Ford, I say unfortunately or fortunately, the Stuart Ford 2, which was a car which had many problems, but it had the first multi-link suspension, rear suspension in Formula One on it, a true multi-link, and it was designed to create maximum space for the diffuser. and providing, proper compliant behavior. The unfortunate thing was that the suspension was attached to a flexible gearbox. So that was a bit of a problem. And then Stewart Ford 3, which was actually quite a good car in its days, it had basically a carryover Stewart Ford 2 suspension, multi-link suspension, only slightly optimized and attached to a proper gearbox. So it was really a good car, and that put it all on. And that's how the non-believers in Formula One became believers. I remember I had to convince Alan Jenkins that we would put a multi-link on, and we built a wind tunnel model with a functional suspension just to prove that it could go up and down. Because that was one of the key things when it was designed. They say, "Oh, does this actually go up and down?" Because it was a multi-link, and it was a new world, a new brave world for them.
What's the benefit of a multi-link suspension? I think we've jumped a couple of steps here and not even gone on to that basic thing. Why would someone want it?
Simply said, you can make more compromises. You can have everything as you want it without paying hugely negative price for any other bits and pieces.
So what kind of things would you want?
For instance, you can have all the kinematic characteristics that you would like to have. So anti-dive, anti-lift, bump steer, camber gain in every combination as you want. And you can have, for instance, a decoupling of lateral compliance steer from braking compliance steer. So you can tune them both separately. Typically on more simple suspensions, you have a connection. For your viewers, there are 3 types of suspensions. It's not like the type of a multi-link or a McPherson thing. It's the concept. You have in-plane suspension. An in-plane suspension is a suspension that you can draw on a piece of paper. So that's a McPherson suspension and a wishbone suspension. You can work them out on a piece of paper with strings, with a very simple computer model. Then the next step, which is called a spherical suspension. A spherical suspension is characterized that the axis of instantaneous movement always goes through one point. So that is a typical 3-link suspension. The BMW M3 suspension, the original one, has got 3 links, and the instantaneous axis of rotation goes all the way through that forward pivot point. It spherifies around that point. And then you have the actual fully 3-dimensional suspension, which means your instantaneous axis of rotation is moving somewhere around in space and is also moving like with a certain thread forward, aft, along the axis to make it absolutely complex. And that latter part does allow you to combine all the advantages into one suspension, but you need a computer.
So for people listening, I'm sure they will have heard of things like roll centers and maybe pitch centers. I don't know. So is that kind of what you're saying about this, these axes of rotation? Is that what you mean?
Exactly. If you're talking about a roll center height, for instance, that is the actual penetration of that axis of motion in the XZ plane of the car on the wheel center line. The same is valid for the pitch center. That's the penetration of that axis in the actual longitudinal plane of the wheel center and Y of the wheel center. So those are just simplified points of a complex behavior.
So the funny thing, sometimes you have a conversation about these and it gets confused fairly quickly. So what are people aiming for if they have roll centers and things like that? How can they use that information to tune their car in some way? I mean, do they care about them? Are they representative? Why should people care about those things?
Well, they should care about them because the first thing that they should understand is that a car has 4 wheels. And that's already a very delicate thing because typically I always tell to people, what's the difference between a table with 3 legs and a table with 4 legs? A table with 3 legs does always stay stable on an uneven ground. A table with 4 legs doesn't. So it starts wobbling, and that's the key thing about a car with 4 wheels. It's an over-constrained system. And that means that the reaction forces of each wheel are depending of the forces at the other wheel and the stiffness at the other wheel. So, simply said, a car has got 4 wheels, 4 stiffnesses, and it has a roll center or roll axis around which it does move. So your roll center is basically also influencing how those 4 springs are reacting their loads against the ground and how these loads are then divided among the 4 wheels. That's why there is so many, discussion about roll centers and balance, because basically you're trying to balance a system which is over-constrained. That's why every Formula One race is so exciting. That's why every setup is so exciting, because they are chasing a system that is over-constrained and have to optimize it for any condition. So if you make a change on the rear roll center, it does affect the front of the car and vice versa. So that is the key thing. So if you want to understand what roll centers does, it's very simple. The roll center is the point or the axis around which the lateral forces do react immediately.
Okay, so just to jump in there, sometimes because of all this compliance stuff we were just talking about, the geometric thing where people have maybe done it with bits of string or lines and drawing things off through the axes of their wishbones or the McPherson strut, and they'll come back to a point and they'll measure it to point something of a millimetre precise precision. Isn't necessarily what you're talking about, is it? It's where the force is resolved, I think, is what you're talking about. That's the only way you could find a roll center on a multi-link suspension, for example. Because
exactly. So if you very simply said, the roll center is lying exactly there where the combined lateral force and vertical force in the contact patch is pointing to at wheel center at car center line. So if you take a certain amount of lateral force and a certain amount of vertical force and you create your vector, that vector is pointing exactly at the roll center height. And it also means that the sum of the forces goes through the roll center. So the roll center is reacting very quickly. As soon as you have a load working on the car, you have a roll center and you have the load transfer due to that roll center. Whereas if you apply a load on the car, and you have to wait until the inertia of the car has created a roll angle on the car, which the roll angle is creating a spring deflection. That is way, way slower. So the roll center is the perfect tuning to set up your reaction time of the rear axle or the front axle. So you do that primarily with roll center heights. And then you tune the actual balance, the mid-corner balance, you tune that as a combination of roll center height and spring rate.
Can you just talk us through that one again? Because people might find that quite fascinating. And so what you're talking, just if I understood correctly, so the roll centers are giving you that kind of initial balance. Is that right? Because we've got the Rocky table analogy. And so basically you've got, it's funny because I wonder how many people are thinking, why don't we have 3-wheel cars? And don't 3-wheel cars always roll over? but parking that bit. So we've got our table, which is not stable. So we've got this thing, and so we've got our roll centers here, and then the roll centers are what are managing initial turn in and feel. Is that right? So, or is it just the way in which the loads start to get transferred and then the springs kind of take over? Just clarify what we.
Yeah, it is that the latter part, that initial vertical reaction of the car. So basically, when you have a high roll center on the rear, for instance, you can build up a much quicker a vertical load transfer on the rear, and that will eventually create slip angle in the tire and get all that process started. And once you have that motion of the car starting to become feelable for the driver, it also is the point where the springs and the dampers are starting to work. And then you go from into that transition of the corner, and then at mid-corner, basically, you have all that effects of roll bar stiffness, of spring stiffness, and of roll center height, which gives you your final balance at the mid-corner. So if you have a nervous entry, maybe you should reduce the rear roll center height. And if you want some more understeer on the car, maybe you could increase the front roll center height of the car to get that entry balance. So the entry balance is quite a bit about roll center heights. And then it goes, obviously, you have to the transition, with your dampers and your bars, you'll have to tune it from there onwards. That's what you typically do with the suspension tuning tools, or with the tools that I provide. So there is the roll center is typically a very nice tool to play with, and there is a simple rule of thumb that you should have roughly 1 degree of roll axis inclination. So, and if you take that on a 2.5 meter wheelbase, you're roughly about 50 millimeters height difference between front and rear. The roll center itself does come, however, with quite a huge handicap, because it does provide some jacking on the car, which basically means it lifts the car up. You just have to look at old Fiat 500 pictures or Renault 4 pictures, or like Volkswagen pictures, where you can see the car is completely, lifting on 2 wheels up in the air and almost about to roll over. But if you look closely, you can see that the outside wheel is not in compression. It's an extension. So roll centers create jacking forces which lift the car up. So you pay at the end ultimate lap time with higher roll centers, because at every corner the car is running a little bit higher than it should be. So you have to balance that trade-off. You do want some initial response of the car, but you do not want the car to be lifting itself up on in cornering, which is reducing your capability of lateral G. Your center of gravity goes up, your roll angle becomes higher, and then eventually you roll over.
I promised everyone it would get complicated, didn't I? You've not even started yet, have you? I mean, this is just going in, because all the things with the calculations with the roll centers, it's all at this kind of nominal ride height. And of course, when you roll, the wheel going into bump and the wheel going into rebound don't move at the same amount.
Exactly. So they don't move in the same amount, and then you have to say, where's my contact patch, because you don't know where your contact patch is. So yes, it is it is very complex. I always tell to people, and that's also what Mr. Machinsky says in his book. You should consider the roll center height important at the beginning of the movement, because your car runs like on a binary, like on a train. You've got that contact patch more or less defined. Once you start building up slip angle and your tire starts deforming, that contact patch is somewhere, and that actual point of motion of where the inside wheel and outside wheel go, they're going diverse. So it's quite complex to say there. But that's one of the reasons why many people use Adams tools to analyze it. The problem with it is you cannot really relate to anymore what's causing what. Adams will give you a correct answer, but it's going to be very difficult to say, oh, this was roll center height, this was camber gain, because you're running a real-life multi-body tool, and you cannot really relate to what is the root cause. You can see a range of results, but pinpointing the results to one particular change in the car is very difficult.
Yeah, these tools kind of give you one on the one hand and then take away some things a bit opaque on the other hand. I mean, let's talk about simulation for a while. So, because your tool includes a lap simulator, or a quasi-static lap time simulator anyway. So what is your perspective on simulation, and how can people use those tools, and how can people think about those tools? Just to put that in context, I've had several guests on the show who are familiar with simulation and they use it all the time, and they often struggle a little bit when people don't appreciate that the simulation is not real. That makes sense. So it's always an approximation. And I think that sometimes gets a little lost in translation if people aren't familiar with it. So, they think, well, I've got this car simulation, and we try and ask it this question, and it can't give us that answer because it's not, it hasn't got, it's not good enough or whatever. And then they kind of, I've seen people dismiss the idea as a result. It's like, oh, that's a load of rubbish. So how would you describe simulation and its role, and how can people use that?
You always have to start with the famous phrase that also Damien Hardy always uses: all models are wrong, some are useful. So that is the start. You have to be, you have to understand that the black round thing on the car, the tire, is rather complex, which makes it complex. The second thing is the 4 legs on the table make it also complex. So if you know those 2 things already, you have a good starting point of using the tools correctly. In my opinion, it's not about the absolute correlation between track and a simulation. It's more like how you compare A to B comparisons. So it's a simulation tool should be a help for you as an engineer to do what if scenarios and to study. My tools are developed they come from an OEM background. So there are many test procedures are open loop. You have a constant radius test, a step steer test, a frequency response steer test. Those are the classical, tests where you say, okay, analyze the car. Putting a lap time in it is more like an added bonus to do comparisons between what if studies. What can I do? And I also added a simple, design a sensitivity study, on the track. If I change, my camber, if I change my toe, if I change my spring weight, what does it actually do on the lap time? And that is for the engineer to get a sensitivity of where he should be paying attention to. So it's not the holy grail, but I'm pretty sure that without it, it will be very difficult to do your job as a race engineer or as a performance engineer. So that is, it's a medium that allows you to reflect and to throw ideas at. So it should be that.
I think that's a great point, because often you can argue both ways. You can say, oh, well, because it's complicated, right? So we have this behavior going on in the car and we want to change it. We want it to go more in a better way. We feel that that's going to give us a faster car or an easier car, and then it's like, okay, how do you do that? And it's, well, we could do this, or we could do that, or we could, and then literally all the ideas keep on getting thrown in, and all of them have merit because they're all based on some experience or some theory that is like, oh, if we make this change, it's going to affect the car in this way. And what's lovely about the sensitivity study that you've got baked in there, and that is, again, something that I was so pleased to see. It's something I've done before as well myself, is that yes, all of these different things, all these changes will make a difference, but by how much? And what is it that we can do in the time that we have available that's going to be the most effective, or give us the biggest step with the least compromises on everything else?
Exactly. So that is the key thing. And one of the things is you do this typical work, you do this upfront. So what a performance engineer normally does is he or she goes through all the variants that she can think of, knowing the track already from a history. You say, oh, what if we do this? And what if we do that? So in 95% of the cases, if the engineers have done their homework well, and if they have, sufficient data of the car, then they can already predict the next step. So from the driver comments, they can say, okay, I'm touching here, or this is, we can do all of this. Again, I'm a firm believer that with a race car, it's slightly more difficult because you have the temperature effect of the slick tire. But I'm a firm believer that if you do your homework well, there is not much magic to the basics of vehicle dynamics. You don't have to be a guru to become a good vehicle dynamics engineer. Again, my 10 easy steps and my 5 fundamentals, the question of the table, I've been asking that question of the table to many of students. And in 30 years, only 4 to 5 people have been able to answer that question. And once you have understood that question, that the car is an over-constrained system, then you have understood vehicle dynamics. You have understood 95% of vehicle dynamics. That's what it's all about. When you change the length of that leg, you change the spring rate of that leg. It's the same thing you do on the car. Why when you change the spring rate on the front, does the car more understeer? Those are all, if you have that question, and if you know that the tire is black, round, and highly nonlinear, you have got 95% of vehicle dynamics covered.
It's knowing the problem that you're trying to solve, I think, or being aware of what it is that we're trying to do, or try and optimize given the nature of the system and the nature of the environment is, like you say, most of the battle. How you go about addressing the platform and what you want it to do. I mean, because there's some people who have got a car that has no aerodynamics on it, for example, and other people have got a car with aerodynamics. So well, do I do the same thing, or should I prioritize one or the other, or how do I manage that additional complexity where we've only talked about springs and wheels going up and down and a bit of compliance, but then you throw in the aerodynamics as well, and then we're off into a different world of complexity again. So it's fascinating. I wonder how we can help people listening with some specific suggestions or tips or takeaways. For example, if they're in a certain situation, yes, you may not have even your simulation, they may not have anything, but what could they do to help themselves or at least better understand their own car?
I always tell people that it's everything about the basics. That's, for instance, when you have a car, and what I said, I have my 10 easy steps. Check your vertical rate, check your roll bar rate, check your load distribution, check your damper settings, check them all and check them whether they are in the ballpark area of such a vehicle. Clearly, if you're doing a Formula 1 car, you're doing it very complex. But if you're going to a Formula 3 car where you have some limited aerodynamics, you have some certain amount of wheel rates, you do need some experience, and I tend to provide in my tools some reference numbers, say, okay, you should be around in this area, you should be around in that area. That's how you can start learning the basics. You cannot be a superb race engineer or performance engineer by just starting by firing up a simulation tool, say this is, it's going to be that. You'll have to walk the path of a performance engineer and learn it. But I always say, check your basics. If the basics are right, then you don't have to worry about that anymore. But if you don't have that, then you'll be running around, use a method, a proper method, the 10 steps that I define, I follow them on every car. When I do a car, I follow them on every car and check them. If a client comes to me and says, I've got a problem with the car, I keep asking, what is it? What's that value? And usually after 5 questions, they say, well, I don't have that number. I don't know that number. So then you say, start looking at that number and work your way through it. Again,
this is all stuff that people can do either with practical tests or some scales or measurements or these kind of things. Yeah, I think having a methodical approach, is super relevant. And also that open-mindedness to learning, I think. You're almost sort of saying it as if it's a given, but often, in my experience, it takes a while for people to have the confidence about learning and to say they don't know, particularly if you've got a driver or you're working with a team where you're the go-to person. It takes confidence to say, actually, I don't really know. We need to do these things and then we'll have an idea. So have you got some tips or thoughts about working with drivers and working in that kind of environment where you might be the main person who's responsible for these things? And
I think there is also, and that's probably a little point of critics to my fellow vehicle dynamicists, many people have also an interest of not telling everything because it is a way of business, of making money. So I have always found that telling the truth is always the best way, and educating young engineers on what they should be looking at. It doesn't help a young engineer to say, well, you need to do this and this, and not explaining them why they should do it. It does solve a problem, but it's not the thing to go to. Equally with a driver. When I work with drivers, I said always, let's change this, and I'll change something on the car, but I won't tell you what it is. I said, you just have to make sure that you pay focus, on a corner entry and so on. And it's not because I'm telling him I do want him to be a bad driver or so. But the key thing is, if the driver doesn't notice the difference, it doesn't make any sense to go down that route. So for a race car engineer, it does mean, well, the car doesn't become faster by that move. For an OEM engineer, it does mean the client will probably not notice it, so I don't have to spend money on it. So that's the key thing, Many professional drivers and many race car drivers also go to the point of saying, don't tell me exactly what you change on the car. Because if you tell a driver, I'm going to change the roll center height, and if the driver has got an experience with roll center height, you're going to say, oh, that's going to be that, it's going to be that. He's already prejudged. But if you tell him, we're going to change the car and come back with what you find better or worse, then it's also easier for the engineer to reflect on the driver comments because he comes back with a proper feedback. It does, of course, mean that you need to have a band of trust between the engineer and the driver.
I was going to say exactly that. I've written it down. Trust. I've actually written it down while you were talking. Yeah.
If you don't have that, but if you have trust with a race engineer and a driver, if they have trust, then they can do exactly that. They can try things out and see whether it works or whether it doesn't work. And again, coming back to the four-legged table, it's always it can work or it cannot work by conditions, because the system can react every day, every minute differently. So that is the key thing, and that's how I tell people, young engineers, young racing drivers, to work in that way. Ask for your engineer to do a blind test, to see if you can find it. We did that all the time. When I used to have my level 4 proving ground testing capability in a super duper Ford level, which would say, and we ran out whether we could find out a tenth of a bar difference in pressure in one tire, whether we could find that out, not knowing. So those are the kind of things that bring you forward, and then you can use your tools as a reference. If you say to anybody, well, my tool is giving you all the answers, you set them up to a certain problem, because A, the tools do not give all the answers, and B, the client doesn't, or the customer of the tool is not happy because he cannot understand the tool and he doesn't understand what's happening. So you need to give that feedback on the thing. I had, it's a funny story. I've got a good friend. I've never met him, but he wrote on a blog somewhere that he had a problem on a car. He's a hill climb racer, from Czechoslovakia, and he said on an Australian blog, he said he had a problem on front suspension, and I said to him, well, are you sure you're on the front? Because it could be the back, the rear end of the car that's causing problem. And I said, really, why? Now, in the meantime, he sent me about 2,000 emails, and he built his own KNC rig. He went from that, and he's becoming one of the most known racing consultants in Czechoslovakia. He's been doing all kinds of cars. We've been doing Sierras, old classic race cars. He's been doing everything, and he started with the suspension tool, with the damper tuning tool. He does the lap time simulation. He's been running it. It's been now almost 8 years. He's been doing it, and he started from being a hill climb racer and a mechanic with simple tools, and he worked his way all the way up. And he's doing everything now. He's doing a KNC rig. He's making big progress, because everybody says, from racing, I don't care, it's stiff. And then he does show them physically on the car that it's not stiff, and he's making progress, with that. The damper tuning, he's creating dampers with that, and it's fantastic. It's absolutely unbelievable. So if anybody out there has got things, I cannot do it. Yes, you can, but it does take a little bit of time.
That's wonderful. That's a lovely, inspiring story, because it does feel like a mountain, doesn't it, sometimes? And you think, I don't even know what I don't know here. And to be honest, as someone who's been doing it a while myself, it still gets me. There's still stuff that I'm learning. I learned something new about the tyres the other day when I was doing some stuff for damping, and it was just like, okay, I didn't think about that at all. And then you read it, and sometimes it's like, oh, that's obvious. But it wasn't. It wasn't before I read it.
It has to become a second nature of looking for new things. People, when they ask me about suspensions, for instance, and they say, well, how can I look what a suspension is? My first reply is, start counting the number of links. So if you take an A-arm 2 links, another A-arm 2 links, a track rod and 1 link, you're 5 links. If you see a suspension where you cannot make out 5 links, there's something fishy about it. You need to dive into it and understand what's going on. Your Focus rear suspension had 4 links, so something is missing there. There's suspension with 3 links. And then you have to start thinking, what does this suspension actually do with 3 links? How does it actually work? How can I, and again, you can find that on the website for anybody. You can see how with 5 links, you can create any suspension, independent suspension. You can create almost any suspension. Once you've understood that principle, suspension become transparent for you. You start looking at 4 links. Okay, there must be 1 link must have a double function. 3 links, 1 link must have 2 or 3 functions. So that you have to start thinking like that. Eyes open and wander forward and ask questions.
I think, yeah, we're always learning, I think, aren't we? And always humble. I certainly am.
Well, me too. I keep learning all the time. That's the fun part of it.
But Paul, this has been absolutely fascinating. I knew it'd be really interesting to talk to you. I'm still in awe of what you've been able to do. And, I wish you every success. Where can people reach you online or, if they want to follow up?
They can always reach me online via, on the website, www.dynatune-xl.com. And there's an info button, as you did, you just hit the info button. You write me, I'll always try to answer questions. I'm very busy at the moment, so it might take some time. And there is if you have, I've got many Formula SAE teams. So there is a frequently asked website, where many people have the questions that I get, where I try to answer them and they can look at that. So it's kind of a bit of a study, the website. If you study it, you're getting already quite a bit of information, probably more questions, but, at least you start on the journey.
I think one of the things there, actually, you made the point, is that if people want to sort of dip their toe into this, some of the reservations or is the amount of information. It's all gettable, but it is quite a lot that you need to get going to be able to start answering these questions and start to create solutions that are going to add some value to you.
It's the most fantastic field of automotive engineering. I can tell you, I'm sure you agree with that. So it's not an easy field, but if you dive into it and you like what you do, it's really an awarding field. And it's a field where you can learn 10 years quite easily and where you can keep on going. So I always recommend people to not be afraid, start the journey and start reading, start looking what other people do and read books. Become a great engineer, and if you want to be a great race engineer, the first step is to start learning and start doing what you like to do.
I absolutely agree 100%. I will get some links and some references for those books, and I'll put them in the show notes below. I'm sure there'll be, one or two just to get people going. So maybe the less mathsy ones. And I just really want to thank you again for taking the time.
Okay, great. Thank you very much. And I'm very humbled with you asking for me to give you some information. Thank you very much.
It's not often I gush so much over a guest, but honestly, I've been so impressed with what Paul has been able to put together in Excel. Perhaps because being something of an Excel guru myself, maybe I appreciate how much work he's gone into it over the years. There's a lot of great information in this show. I hope that Paul's table analogy and especially our detailed conversation about roll centers helps you think through how you can start to control and get more from your car on track. If you like this episode, be sure to subscribe to the podcast and visit us at yourdatadriven.com.